Okay, so remember we're talking about bivariate correlation. Bivariate just means two variables, and a correlation will tell us how much, if at all, these two variables are related to one another. So here in SPSS, I have our two variables from example 15.1 in the Privatera textbook. We have mood and eating. So mood on some kind of rating scale from looks like 1 to 7, and then how many calories you eat. If you remember from the last video when we were calculating these, we found that there was a negative correlation such that the higher your mood, the fewer calories you were eating. So higher moods were associated with fewer calories consumed. Now I want to show you how to do a couple of things in SPSS. The first thing I would like to show you is a scatter plot. Scatter plots are one of the central parts of looking at the assumptions specifically for correlation, pardon me. So here we have our data up. If we go to graphs, legacy dialogues, this gives us several options on how to display this data. Again, we're doing what's called a scatter plot. So if you choose scatter/dot, that will give us a scatter plot. Now, there are multiple kinds of scatter plots, but of course we want a simple scatter plot. No need to make things more complicated than they already are. Go ahead and hit define, and it has a bunch of options for us that we don't really need. In the example, I think we said that mood was our x variable, so we'll just move we'll move mood over to the x-axis, pardon me. We'll move eating over to the y. We can add some titles if we wanted. We have some options that we can do. We're just going to move those variables over, hit OK, and take a look at this scatter plot that it produces. Now, here we can see it's very similar to what you can get in Excel. It's automatically labeled some things for us, mood on the x, eating on the y. And we can see again, it seems that higher scores for this mood variable, the fewer calories that are eaten. That in fact reflects our negative correlation. Remember, if it was a positive correlation, our data would be going the opposite direction. So I'm trying to show that with my cursor. Hopefully you can see that in the video here. Now, this looks good. We didn't check normality. Again, check your skew, check kurtosis, do your histograms, all of those kinds of things, but you guys know how to do that by now. We can look at this, we can check for homoskedasticity, we can check for linearity, and I think we're good to go, as we typically are with these kinds of class data sets. So from there we can run our correlation. To do that, we go to our friend Analyze. If you go down, you'll see Correlate. Analyze, Correlate. Bivariate, we have two variables. Analyze, Correlate, Bivariate. And look at here, you move mood over to your variable, you move eating over, and then it gives you several correlation coefficients. So in this class, we're really just focusing on the Pearson R. Your textbook talks about a couple of other. I would like to focus on Pearson R. That's really the base. That's what you're going to come across most as you're reading research in the future. So let's just stick to that and move on. So we'll keep all of these clicked to their defaults, move our variables over, and hit OK to see our variable. Or our results, pardon me. So here we have a correlation table. Now, you have a Pearson correlation, so that's going to be in this row. You have the statistical significance, so that's our p-value, and then you have your n, so your count, the number of people. Remember, we had data from 8 people. Now, you have variables over here, so we have mood right here, we have eating right here, we have variables over here, we have mood here and eating here. So if you go to this number right here, this number right here, the correlation, the R value is a 1. This is a perfect correlation. The reason for that is you are correlating mood with mood. When you correlate something with itself, of course, the variance, the change in those variables will be exactly similar, so that is why it is 1. If you go down here to the lower right box, you have a perfect 1 correlation again. You have eating correlating with eating, and that's a perfect correlation, of course. The correlation value we're really interested in, though, is the correlation between mood and eating, which of course we find is negative 7.44. Now, SPSS put an asterisk here for you to tell you, hey, this number right here is less than 0.05. This is statistically significant. Of course, we're all able to look at this 0.034 and ascertain that, hey, yeah, it's less than 0.05. I didn't need SPSS to flag that for me, but it did anyway. So we do, in fact, have a statistically significant correlation. Your textbook talks about how to look up these p-values, your critical value and all of those kinds of things by hand. So you'll be doing that for your homework assignment. We'll do an SPSS assignment for regression, not for correlation. This is pretty straightforward for you, I hope. So we have an R statistic of 0.744, and it is statistically significant with a p-value of 0.034. So that is correlation in SPSS. If you have any questions, please do email me.